I'll say hello to all the listeners who are out there. My name is Abby Bauer, and I'm one of the associate editors for Horde's Dairyman magazine. I would like to welcome you all to this webinar today. Horde's Dairyman and the University of Illinois have been co-hosting these presentations since 2011. It takes a team to produce every webinar, and we surely appreciate the work of our webinar producer, who's Jim Baltz at the University of Illinois, and our Horde's Dairyman online media manager, Patty Hirchin, who does a lot of behind-the-scenes work to pull these events together every month. My co-host for today is the well-known and very respected Mike Hutchins from the University of Illinois. And together, we have the pleasure of welcoming Jack Britt of Britt Consulting as our webinar presenter. We are very excited to have him with us, and his presentation, titled Dairying 50 Years From Now, will discuss how population shifts, changes in climate, and technology will impact the location of farms and cow health and productivity in 50 years. This month's webinar is sponsored by De La Valle, and we certainly thank them for their support of this program. Couldn't do it without their financial assistance. Mike, please take it from here to further introduce our speaker and kickstart this month's webinar.
Well, thank you very much, Abby. It is my personal and professional honor to introduce Dr. Jack Britt. Dr. Britt has got 66 years of experience in the dairy farm after growing up on his family dairy farm in Kentucky. He was a faculty member and leader at Michigan State University, North Carolina State University, and the University of Tennessee system. He has worked with dairy farmers from North America and many other countries. And over the last 3 years, he, along with some of his colleagues from the United States and Europe, have developed a forecast of what dairy cows and dairy farming might be in 50 years. So, Jack, with that very brief but hopefully useful introduction, we will turn the program over to you for today's webinar.
Thanks very much, Mike and Abby. I appreciate the opportunity to participate in the Horde's webinar. I've been a Horde's reader for many years and like to follow the webinars when I have the opportunity. As Mike indicated, we started this project in 2015 because Michigan State University had asked that I speak at one of their conferences and talk about the dairy industry in Michigan 50 years in the future. And so I put together the team that you see on this slide. They're from the US and abroad, and we've been interacting and engaging regularly since that time. And so this is a moving target. We keep refining and adding to what we have forecast, and today we'll be sharing that with you. Before we get very far ahead, I want to just indicate that we can look back. As you see in this picture, we built this dairy barn that you see attached to this old cattle barn in 1954, or excuse me, 53. The cow that you see was born in 1954. So I go way back in terms of dairying in its early days. We had the second milking parlor in our county. There were lots of small grade B herds in our county and just making the transition to grade A. The cow you see there was 10 years of age. She produced the record that was 6 standard deviations above the average at that time, but the average in 1954 was in the 6,000 pound range. Today, that cow would be producing equivalent of 35 or 40,000 pounds if she had a relative production compared to today's cows. First question I think it's important for our export market to look at population growth over the next 50 years. And so the first poll is, which country's population will grow the most in 50 years?
Well, Jack, this should be pretty exciting. Abby, you want to vote on this verbally? You can't legally. I can't vote, and she can't vote here. But we have Africa, Asia, Europe, North America, and South America. I know who I know 2 to eliminate pretty quickly here. So our people are off and voting here, and we welcome our listeners to vote. And once we get up to about 70%, we are almost there. We are going to give you 5 more seconds to vote, and we are going to close the poll. Abby, did you vote?
Well, I'm going to put my vote for Asia. I think they seem to be growing and everything, so that's where I'm going. How about you?
Well, I think I would also go I was going to go South Africa, but I could be wrong. But anyway, Jack, what do you think? Here's what your listeners are voting.
Yes, actually, Africa is going to have the greatest growth in population. And in fact, it will be dramatically greater than any of the other countries, and we can see that on the slide. If we look at the population over the next 50 years, we can see that the growth in Africa is going to be tremendous, adding up more than 2 billion people. We're going to be up around 10.4 billion people by 2067, 2068. And you see the majority of the growth is going to be in Asia and Africa, with the predominant growth in Africa. We'll have very little growth in Europe, Latin America, North America, Oceania. And so if we're talking about our export market in the future, Africa and Asia are going to be the places where we have another 3 billion people to feed. And that's going to be important for us as we look at the markets in the future. One of the questions that's often asked is why dairy? If we look at dairy, it produces the most protein per acre of cultivated land. This is a study that was done a couple of years ago, looking at various diets that we might consume in the United States. And you see we have a dairy diet that ranks #1, an egg-based diet #2, the vegan diet rates 3 or 4. And basically that's because our dairy and egg diets produce more of the essential amino acid and more of the nutrients that people need per acre of land than other diets. And so we think that the world is going to continue to consume more and more dairy. All the evidence is that that's happening. And so there's going to be a big demand, large demand in dairy over the next 50 years, particularly outside of North America and the developed countries. Also, if we look at dairy, it produces protein for human consumption very efficiently. On the left, you can see that dairy produces more protein it takes less land per gram of protein to be produced than lots of other foods that we consume. It ranks very well with wheat, and it ranks better than eggs and poultry. So that's an advantage of dairy. And if we look at the amount of greenhouse gases that are required to produce milk, you see the North American cow produces a milk or a real milk more efficiently than North American soy-based milk drinks or coconut almond-based milk drinks. And so dairy is very efficient in producing the food we need for human consumption in the future. The question from Australia was that, do you believe that synthetic milk will be a threat to the dairy industry in the future? We've actually done some calculations on this, and the most traditional kind of fermentation for making a product that we know of is beer, because beer has been made for centuries, and it uses a fermentation process very similar to the fermentation process that's been proposed for milk. And today, even with that efficient production of beer, it cannot be produced as efficiently, energy-wise and cost-wise as milk. And so we don't see any real basis for milk competing effectively with dairy from a cost and efficiency standpoint, although some people might want synthetic milk because they don't want milk coming from cows. So that would be a possibility, but we don't believe that's going to happen over the next 50 years. The other thing that is going to happen over the next 50 years is that the dairy prices, the prices that farmers are paid, are going to continue to be volatile. These data show the average prices per kilogram of milk solids paid to New Zealand dairy farmers over the last 20 years. And this has been adjusted for inflation. So we're looking at constant dollars. Over that 20-year period of time, there's been a 75% difference in the highest and lowest values paid to dairy farmers for milk solids in New Zealand. And we think that volatility is really associated with our ability to increase production greatly when we need to, but we don't decrease it very quickly when we need to. And so that's going to continue to add to volatility in the world dairy market for the years ahead. The other thing that's going to affect dairying over the next 50 years is the change in climate that is predicted, that we anticipate. This shows the average climate deviation from the century's average in 1961 and 70. You see it's mostly below the century's average. As we go forward, it begins to get warmer and continues to get warmer and continues to get warmer as we move into our decade now. And so over the period of time, we see a consistent trend in increasing temperatures around the world. This is an example of temperatures in North America here, but certainly the climate change is going to influence dairy. Climate change is also going to influence where water is located. This is a map of the United States showing the water stress levels, or the lack of water, if you will, in 2050. These were projected numbers. The darker areas are areas that have less water. The white or brighter colored areas are areas that have more accessible water. And water, of course, is very important in producing milk. 42% of the milk today is produced in areas that have a deficiency of, that are predicted to have a deficiency of water in the next 50 years. And if we look at where that milk comes from, it's coming from the Southwest and the South, 42%. And we think that the milk that's produced in those areas will be replaced because those dairies are going to be moving to other areas of the country. We anticipate an increase in number of cows that are moving to the upper Midwest, to the Great Lakes region, and even into the prairies of Canada, because those dairies that are now located in water deficient areas are simply not going to have enough water to grow the crops and to produce milk competitively in those areas. And so we believe that cows will move not only in North America, but we think the same thing will happen in Europe and Russia as cows move northward as the climate changes. The other question that's often asked is how much cows will produce, how much milk will cows produce in the next 50 years? So we have an opportunity here for a poll.
Oh boy, here we go again. Abby, get your ears on here. Our listeners, you got 5 choices. 25,000, and in 50 years, that's one of us isn't going to be around at that point. But 25,000, 35,000, 45,000, 55,000, 65,000, and the votes are really coming in here. Abby, are you going to stick your neck out? I have no idea. I think I'm going to go 55,000, but boy, 50 years, that's a long ways away. That might be too high. Abby, you want to take a shot at it?
Yeah, I think my guess is 45,000, and even that seems like a tremendous jump, but with all the changes in the dairy industry, technology and everything, seems like it could be possible.
Wow. Well, Jack, well, listen, Jim's going to show it right now, and so the people will see it as well. So what do you think, Dr. Britt? Looks like a bell-shaped curve to me, but here we go. What's your take?
Well, we think that cows are going to be producing in the 50 to 55,000 pound range on the average. That's based on the selection criteria we have today, but we think the selection criteria may change a bit. And so we may pull that down to the 40,000 range or so. Let's look at what milk yield has done over the last few years. This shows the actual milk production in the United States for all dairy cows over this period from 1945 to 2015. It was increasing about 5.3% per year over that period, and that's very similar to the increased yield of corn over that time, so showing that our ability to improve yields in both plants and animals has increased. We know now we have a top cow producing over 78,000 pounds of milk. We have herds in the 44,000 pound range. The top state, Colorado, is producing an average 26,000 pounds of milk per cow. So clearly the milk yield is going to increase over the next few years at a continuing rate. If we just do linear, extrapolate that straight line, we're up in the 35,000 pound range. But we think it's going to be more than linear because of genomics and because of increased management. We think that production is going to increase at a faster rate. And this projects out to be about 77,000 pounds, which is probably beyond what we will average. Our projection is we'll be around 55,000 pounds. Mike and I and the team discussed this a lot, and this is where we ended up with a number. Clearly, we've got cows producing at that level today. We have a lot of 50,000 pound records, and our rate of improvement may reach that level. One of the things to look at on the right, you see the numbers of cows, the millions of cows that we would need with production in the 30,000 pound range or up in even the 70,000 pound range. And you see in both cases, we will need significantly fewer cows 50 years from now to meet our domestic needs. So if we're going to keep the number of cows that we have today, we're going to have more and more of our milk that has to go into the export market in order to justify having the 9 million cows or so that we have today. The other question that is often asked is, are we reaching the biological limit? Are cows reaching the limit that they can produce? And we ask that question ourselves, and we ask it about cows, and we ask it about corn, and we ask it about soybeans. In 2014, cows in the U.S. averaged about 22,498 pounds of milk. That ranged from, for 2/3 of the cows, from about 18,000 up to essentially 27,000 pounds of milk. But you see our top cow is producing 78,000 pounds of milk. That's 12 standard deviations above the average. So we don't see any limit in terms of the biological limit of cows producing. And that curve continues to move upward. And as the average moves upward, the top cows move upward. So there's no evidence that biologically cows can't produce significantly more milk. The problem we do have in the marketplace is that we have an imbalance between what cows are actually producing and what we're utilizing in the US. And you can see that we're using about 96% of the fat we produce, but we're only using about 82% of the skim milk we produce. And so that puts us in a situation that we have to deal with that imbalance by exporting those components that are in skim milk. You can see we're exporting 73% of our lactose, 59% of our whey protein concentrate, quite a bit of our powder, and almost none of our cheese, if you look at the bottom 3 lines, in butter. So we're consuming fat and fat-based products, and yet we're not consuming sufficient quantities of skim milk basis. And so that means our composition of our milk probably needs to change in the future. One of the things that I looked at recently was, what is the composition of the top yielding cows in the United States? We always seem to have a lot of publicity when a cow breaks the national record in terms of yield. And I said, well, what about the value of the milk? And the numbers that you see here are the top 20 yielding cows in the United States of any breed. And so I took their actual production and the milk composition and used the class 3 prices from November 2017 to calculate what that milk is actually worth. And you can see that it ranges. The number 2 cow's milk was worth $14.12 per hundredweight. Number 10th cow's milk was worth $21.28 per hundredweight. So there is a significant difference among the cows in terms of the value of their milk. And this makes me think about the fact that we ought to be standardizing our milk yield among cows to adjust for differences in fat and protein. And I think that's a more equitable way of actually comparing cows, and we hope we'll be doing that in the future. The next thing we're going to look at is the change in sensors and robotics and algorithms and automation that will be used in the future. This is an unusual image from an automobile manufacturing plant in Alabama, a Hyundai plant, and you can see that robots are building these cars with almost no individuals in the picture. If you look closely, you can see 2 individuals here. And so we're going to be seeing the same sorts of changes in technology on dairy farms, with a lot of robotics and automation replacing manual labor on farms in the future. We believe that we'll see integrated sensors and systems in our soils and crops and our lagoons and our silos and barns and milking centers. And these will all be interacting in a way that we have signals coming from each and being interpreted by others. So for example, the sensors in the soil will tell us information about the crops that are growing there and their nutrient compositions. So when we plan to harvest those, we'll already know what those nutrient compositions are going to be. The sensors in the silos are going to tell us things about digestibility. They're going to tell us things about the quality, about the fermentation that's going on there. The sensors in the barns and the lagoons are going to tell us about the nutrient wastes and how it ought to be managed. We're actually going to have sensors in cows. If you look at the slide, the bottom left-hand panel, that actually shows the little bitty square, the picture shows cells growing on a sensor. And so we will have these biodegradable sensors maybe implanted in the mammary gland and the liver that would tell us a lot about the metabolism and health of the cows. And so we're going to be using that information through really artificial intelligence to make decisions on the farms 50 years ahead. The other thing that we will continue to see, we think, is a change in the size of herds. If we go back and look at 1969 on the left, you see that nearly all the cows were in herds of 100 cows or less. The majority of cows were in herds of 20 to 49 cows. Move over to 2017 and you see the majority of herds are in, or majority of cows are in herds of over 1,000 cows, or over 2,500 cows, as you can see. So that shift continues, primarily driven by the efficiency of larger herds in terms of fixed costs per kilogram or pound of milk produced. And so we see that in not only in the United States, but every developing country in the world is seeing that shift in number of cows per herd. And even in developed cows, we're seeing that. Even though we have large herds in the US, New Zealand today, the average herd size is twice the average herd size in the US. So even in countries that have completely different production systems, we're seeing an increase in herd size over time. One thing that we believe will happen, that may happen in the future, is what we call lateral integration. That's where farmers begin to work together to share some of the facilities and equipment and resources that are required to produce milk to make it more efficient for everyone. This would start out with what we call a shared maternity and transition barn, where all the cows would spend their time between 3 or 4 weeks before calving and 3 or 4 weeks after calving. And the cows in here would get extremely good care, would be in a lower density type of housing, and would be milked 4 times a day, the fresh cows. We know that milking 4 times a day boosts milk yield when cows move to 3 or 2 times a day later on in lactation. After the transition facility, we think cows would move to various herds. These would be identical layouts. They might all be robotic systems that are the same. They may be rotary robotic systems that are the same. They could vary in size, but cows, once they had been in the system and gone through one lactation, could actually move to any of these milking facilities in the next lactation and already be accustomed to that kind of facility. Having identical facilities actually reduces cost. It reduces the cost of operations. It gives you a lot of flexibility in handling the cows and handling facilities when you have facilities that are designed similarly. We believe that we'll see shared heifer raising, shared nursery facility for calves, a shared dairy beef opportunity, which can produce beef that consumers want, and a shared dry cow facility. So this is somewhat analogous to what we see in vertical integration in the poultry and swine industries. But in this case, the cows will be owned by the farmers and the land where the crops are produced by the farmers. And it'll be lateral integration in terms of just sharing facilities to reduce costs and reduce fixed costs and to increase efficiency of producing. We think that these farmers would share feed centers. These would really be the centers that harvest and store the feed. We would have driverless vehicles that move from these feed centers to where the milk cows are, or the heifers, or the other animals that are to be fed. This actually greatly enhances the efficiency of producing feed and makes it more competitive as these herds share resources and share facilities. We've already indicated that this would reduce fixed costs per cow. We would anticipate that we would adopt common protocols among these facilities, so workers could move from one facility to another if there was a need to share labor. That would work because the practices in terms of managing would be similar from herd to herd. Purchasing would lead to volume discounts, as we see as herds gets larger and as farmers share opportunities. And we'd have commonly designed facilities, and so you'd be able to build facilities at a lower cost if they're all designed similarly. So these are some of the changes that we see occurring in the future. Actually, we look around the country, we already see some of this occurring in some parts of the US and also in some parts of New Zealand. The question was, will we see automated rotary parlors 50 years in the future? I think we absolutely will see automated rotary parlors. These parlors that we show here could be the robots that we see today, or we could see automated rotary parlors in the future. The automation systems are moving rapidly, and I think we will see rotary parlors with automation that will operate very much like the robotic systems we have today, with no one actually being present during the milking process, but simply managing the cows and checking on things regularly to see that the system is working. One question that came in early was, what about bedding? How are we going to handle bedding in the future? And this particular question is focused on using sand for bedding and how much sand is used per stall per day and how much actually goes on the soil. I think what we'll see in the future are two things happening. One is that the waste stream will be managed differently, will be processed differently. We'll be actually taking that sand out of the waste stream. The waste that's in the stream will be used to generate energy, and actually will be used to generate specific fertilizer products that will go back on the land. It's going to take scale of operation to be able to do that. You can either do it in one unit, or you can do it in these shared units that we see here, where those nutrients in the sand that's used will be recycled and reused more efficiently and more effectively than we do today in many cases. We'll also see some changes in feeding in the future. Right now we feed a lot of corn and a lot of alfalfa. The corn is all annual. We use a lot of annual crops. We'll see a lot of perennial crops in the future that have high sugar contents and high biomass. Some of these will be coming from what the so-called energy grasses that are in development today. These grasses are high in sugar content. That's what they want for producing energy. As we can increase the digestibility of these, this could provide a great feed for dairy cattle with a high forage yield and high energy yield in terms of sugars. We think this is the kind of feed that could be used in the future. And some of these crops, once planted, will be harvested for 20 years before they're replanted. We'll also see some perennial corn. There's a lot of progress being made in developing perennial corn as a crop. That will allow us to plant corn perhaps every 4 to 5 years, 3 to 5 years, and yet harvest it every year. And that's simply much more efficient in terms of feed production and has much more beneficial effects on the soil. Genetics in the future is going to be similar in many ways, but different in several ways than it is today. We're going to see cows that are developed based on genes rather than breed. We'll be paying a little less attention on breed. We'll still have breeds, but we'll be moving some genes from one breed to another breed, perhaps using gene editing as a way to do that. That's not genetic engineering. That's really just a fast way of breeding or crossing cows. Cows are going to be somewhat more efficient, smaller environmental footprint, certainly healthier. And there may be some proprietary genes that are licensed through embryos from the breeding companies. If they identify some genes that are really valuable, we could see that happening. Maybe they're producing a specific product, a high quality product, or something that is a great advantage in terms of its milk qualities. And those might be licensed to farmers, so they couldn't sell any breeding stock out of those cows. If we look at what happened since genomics was implemented in 2009 in the United States, we see that milk, the increase in rate of improvement is much greater in fertility and health than in milk. In fact, milk has increased about 0.5 rates or increments, 50%, if you will, over the genetic progress in the past. But health and fertility has increased 300 to 400%. And this is going to continue as we learn more about the genes that affect health and performance. And we're going to see much greater progress in those areas in the future than we have in the past, because we really are beginning to identify the targeted genes that really lead to better fertility and health. The next question is, what % of the performance is genetic? So the poll is on its way.
Yeah, the poll is now open, Jack, and I assume this is currently what you want as of now or in the future when you say what percent of performance is genetic. Is that today? That is today?
That's today.
All right, today the polls are open, and we're going to have less than 20%. Abby, you better get a streak. I'm two polls ahead of you here. 20 to 40%, 40 to 60%, or greater than 60% genetics today. Okay, I'm going to go. Boy, I'm a nutritionist, Jack, so that could be a little bit of a bias. I'm gonna say 20 to 40, but in my heart I would say less than 20, but I'm gonna 20 to 40. Abby, what are you gonna vote?
All right. Well, I'm not off to a very good start, but if you're taking 20 to 40, I'm going to go with less than 20. I think those outside factors really have a big influence on it, but we'll see what Jack says.
All right. Well, we got a bunch of Democrats today, Jack. They're voting really fast. We're at 72%. Jim, let's show this, and we'll let Dr. Britt decide quarterback here. Jack, what do you think?
Well, I think that represents, I think, the opinion of what most people would say. The 20 to 40% and 40 to 60% is getting a lot of votes. But really, we need to look at what the geneticists say. This slide actually comes from Bennett Castle at Virginia Tech. He looked at the heritability, the black areas on the left, and this is the heritability of various traits, from the incidence of mastitis, you see, which is very low, to butterfat percentage, which is very high. If you average all of those values on the left, it's 19%. So our answer would be under 20% if you look at all traits. And so that means we're leaving about 81% that is not controlled by what we call our DNA sequence or our traditional genetics. And we refer to this as epigenetics, which means the environment is affecting genes in ways that do not change the DNA sequence, but change how those genes actually operate in the animal. And so we're going to take a look at some of those examples. One of the examples I'm going to use is from a study that we did back in the 90s. And if you see that box in the middle on the top where it says bovine practitioner, we looked at some Holstein cows and their body condition score changes over the 5 weeks after calving. And you can see those that maintain their body condition had a 64% conception rate when they were bred at 80 to 81 days after calving. Those that lost condition had a 25% conception rate. Huge difference based simply on the body condition loss in the first 5 weeks of lactation. Now, we put together an idea about what was happening, and on the bottom, I want you to see, let's look over at the right where it says plus 80. On plus 80, that's when the cows would ovulate and be bred. And that egg at plus 80 actually starts developing about 21 days before calving. If we go over all the way on the left side, you can see where it says minus 21. Those oocytes, or those eggs, are sitting in the ovary, and they're activated and begin to grow at various times. And so that's 101 days from the egg, when the egg is activated, until it's ovulated. And we believed, and we forecast, that those weight losses during the transition period were affecting those eggs and making them less fertile. And of course, that was a hypothesis for quite a while. But in recent years, we've come to find out that that hypothesis is accurate. The figure on the left with the 3 bars show a study from the University of Wisconsin, published in 2014, 1,800 cows in this study. These cows were all bred by timed AI. All bred by timed AI in commercial herds, in 2 large commercial herds in Wisconsin. They monitored what happened to the body condition score during the 3 weeks after calving. Some cows lost condition, some maintained condition, and some gained condition. And what you can see is that those cows that gained condition in the first 3 weeks after calving had an 84% pregnancy rate to timed AI. And clearly this says that if we can change the weight loss that occurs in cows around calving, we can change fertility. 2 studies that have been done just in the last couple of years One in Israel, it shows there are actually two groups of cows or two classes of cows. Some of them don't lose as much weight. And when we select those cows, they have much higher fertility and better health. And then folks in Switzerland have found in brown Swiss bulls that transmit what they call more robust daughters. These are daughters that don't lose weight, have much higher fertility. So we think there's going to be a much stronger emphasis on this in the future, selecting bulls that produce daughters that are healthier around the transition period, don't lose as much weight, and simply survive and stay in the herd longer. There's several epigenetic things that we can do right now. For example, if you milk fresh cows 4 times a day for the first 3 weeks, and then you continue to milk them twice a day thereafter, they will produce more milk than if you had milked them twice a day the entire lactation. So simply milking more times the first 3 weeks actually changes the genetics of the cells in the udder so that those cells continue to provide more milk throughout the entire lactation when cows are shifted to twice a day milking. Same thing is true with calves. We now know that if we can maximize the amount of weight that calves gain during the first 70 days after birth, through feeding and management practices, those heifers produce more milk in their first lactation. So these are responses that occur over time that extend into weeks, months, or even years after the action occurs or takes place. And so this is really what managing the epigenome means. We'll also be managing the cow's probiotics. I use the term probiotics because that's familiar to most of us. Probiotics are really the microbes that live within the cow's uterus, within the cow's mammary gland, within the cow's rumen, and managing those in a beneficial way. We're learning a lot about that, and this is going to be one of the areas that grows tremendously over the next 50 years. This shows the difference in the microbes in the mammary gland or in the quarters of cows that have healthy udders or have mastitis. And if you just simply look at the difference in colors of the bars on the left, you see there's a big difference in the microbes that are there going from healthy to clinical mastitis. And one wonders in the future if we won't be able to use a culture of microbes to infuse in the udder of cows as they grow dry or infuse in the udder of heifers that will produce a more healthy mammary environment rather than using antibiotics to try to get rid of those organisms that we don't want. We believe that moving to managing the microbiome will be one thing that we'll see take place over the next years in the mammary gland. Also, in the rumen, this is a study from Israel in which they were feeding the cows at the same TMR. These were all first lactation cows getting the same TMR, but on the left you can see those bars going up and down. Even though the cows were receiving the same TMR, they had a different ratio of organisms in their rumen. And then the graph on the lower right shows that if that ratio is right, the fat test changes a lot. It goes up in those cows. So even though the cows were feeding the same TMR, the rumen organisms were dictating what the fat percentage was in the milk. It now seems that rumen organism profile is established at birth. So we think probably around the time calves are born, we will actually inoculate their digestive system and rumen with the ideal set of organisms that will have them have a healthier rumen and produce at a higher level, particularly fat level, as adults. We're going to see a lot of herd and specific management practices that take place with these microbes or with these probiotics. We're going to be putting them on seeds and in soils and in crops. Already there's some available for putting on corn that will increase yield about 5 bushels per acre, just one organism without increasing any fertilization rate. I think we'll see them going in drinking water, wastewater irrigation to manage the environment on the farm, to improve the environment on the farm, in manure, bedding, and facilities. There will be specific ones for cows that will be delivered to individual cows with robotic feeders. And there may be some that are prescription, that are offered to cows, given to cows as we do with therapeutics today with infusions or intramammary administrations or intrauterine administrations. So we'll shift from using chemical antibiotics to using beneficial microbes in the future to manage the health of cows. The final thing that I want to, let's went too far here. The final thing that I want to talk about just briefly is looking at the herd as a superorganism. And if you look at what animal scientists have done over the years, they've started out studying the animal, and then they moved to studying the organ like the liver or the rumen or the uterus. And then they started looking at cells. And then finally today we're looking at genes. But really genes don't tell us anything about herds and how they behave. And so we think that we need to think about herds like some of the other organisms that we see. Beehives and termite hives and ant hives or ant colonies and starling flocks are referred to as superorganisms because the entire hive or the entire colony eats together, feeds together, is exposed to the same diseases, exposed to the same environment, much as dairy herds. And so we need to understand in the future, what is it that makes herds differ? Herds that are in the same region. And so, for example, if we look at this example in the Midwest, we see in this picture, this image taken from satellite, that there are 13 herds located in an area that is 8.5 miles wide and 5.9 miles tall. Essentially, all of these herds are feeding the same types of crops. They're certainly in the same environmental area, the same soils area, very similar production and environmental conditions. And yet those herds differ significantly in terms of their yield or their butterfat and protein tests. So we need to understand what are the things that go on at the herd level. What are the practices? What are the protocols? What are the management steps that are taken that cause herds to differ? That probably will tell us more about what we need to do in managing our herds than studying individual cows and individual cells and genes and so on. So we think this is an effort that needs to be undertaken by the industry in the future if we want to really understand what causes herds to be different and how to manage herd more effectively in the future. I want to thank you and thank Hordes for this opportunity to participate today. And I think if we talk about the future, if we can envision the future, then we can create the future. There are many examples of industries that and examples of tasks that we've undertaken in the past that were driven by our vision for the future. And I think our dairy industry, particularly in the US, needs to have a vision of what it's going to be like in the future if we want to be successful.
Okay, Abby,
I think it's time to move on to questions, Ian.
Yeah, Abby, do you want to mention the next upcoming programs?
Yes, I'll do that, Mike. Thank you, Dr. Britt. That was a really, really interesting look 50 years down the road and what the dairy cow might be able to do at that time. We had a great group of people in the audience today and just want to remind you all that the webinars are archived. So far to date, we've had more than 126,000 views of our webinars that are online, and we hope that number just keeps growing. If you want to view this webinar again or any previous webinars, you can visit the website at www.hordes.com/webinars. Also want to let you know that you will receive a 7-question email survey later this week. That survey will ask you some questions about today's presenter and topic, and we use that feedback to help us plan for future webinars. So we appreciate you taking the time to fill that out. We hope that you'll make plans to attend our next webinar, which will take place on Monday, April 9th. The title of that presentation is "There's a New Calf Killer in Town, What You Need to Know About Salmonella Heidelberg." And that presentation will be made by veterinarians Donald Sockett, Rachel Kloss, and Jason Lombard. And they will talk about this new strain of Salmonella Heidelberg that's kind of taking the industry by storm and not in a good way. The following webinar, if we look ahead to May, will be Calf Raising Affects Lifetime Behavior. That will be presented by Trevor DeVries from the University of Guelph. So another calf topic there. And that webinar will be sponsored by AAS. So Mike, now would be a great time if you want to share some of our listener questions and have Dr. Britt go through some answers for those.
Very good. Well, we do have questions, and get ready, Dr. Britt. Here we go. Early in the webinar, you mentioned about Africa becoming a larger future demand. What about lactose intolerance? Is that going to be a problem when we go to that population?
I think that's an excellent question, and it could be a problem. And we now have the opportunity, I think, to change our milk in ways that it won't be a problem. One of the things that I think we need to do is we need to have people that, from a product standpoint, in Africa today, asking folks there, what kind of foods do you like? Developing some potential foods and testing them there. And they may be lactose free. We can either add lactase enzyme to remove the lactose, or we may just filter out the lactose. And because we're going to be shipping them not liquid milk, we're going to be shipping them products. And so maybe removing the lactose in some of the fluid is going to be essential for developing the products. One of the things I see us not doing, the New Zealanders are doing, the Aussies are doing, the people from the UK and EU are doing, they're spending a lot of time in countries talking about products of the future and developing those products. And more than half of the large dairy companies in the world are owned by European companies. And so they're looking at their opportunities in the future to have customers outside of Europe. And so we need to be doing that, I think, in the US.
Another question, Jack, has to do with the human side of it. Do you think that's going to be a problem? We talk a bit about infusing to the mammary gland or putting organisms into baby calves, GMO type things. Is that going to be a roadblock or limitation or no problem at all?
Actually, Mike, I think the using natural organisms, probiotics, will be well received by the public who consumes our product, because they're using a lot of probiotics now. And we put probiotics in yogurt, for example. We have milk with probiotics in it. And so I think that they would be much more receptive to using probiotics that are natural organisms than using artificially made antibiotics and artificially based drugs. So I think that would actually is a step in the right direction.
Okay, another interesting question. As the number of farms and affiliated support industry shrinks, will the dairy research dollars also drop, therefore making predictions of technology progress? Might that be over-optimistic because there's no dollars to develop in the next 15, 30, 50 years?
Well, I think it depends on where we look for dollars. I think that in the US, we're probably going to be spending less on dairy research, but the world as a whole is probably going to spend more on dairy research. If one starts looking around the world where dairy is going, where dairy consumption is going to increase, there are resources there that we could utilize, particularly in developing products. And if we can develop products, that means we're going to drive continued number of dairy farms and continued number of cows, and that's going to drive innovation in the US, and it's really going to drive innovation around the world. So there's an opportunity to look outside the US borders for funding for future dairy product development.
A follow-up question, do you think that's going to be more industry-based rather than government-based? You know, in other words, people who sell the sensors are going to develop that technology.
I think that some of that's going to be developed by the industry, the sensors and technology, and a lot of that's going to spin out from other industries that are developing sensors and technologies and robotics and manufacturing and all sorts of industries. But also I think some of the dairy development work in terms on the food side, product side, will be driven by the governments, because they know what kind of products their population needs, and they're going to fund work, and actually are already funding work on developing those products that be specifically useful in their countries. In 2067, Nigeria is going to be larger than the United States in terms of population. So we need people in Nigeria today working with those leaders and working with the people who provide food and food service to the people of Nigeria, and to find out what kind of products they need.
Interesting. Here we go. Get ready. Remind me, this question comes in, what was the source of the graph on genetic impact? I believe it was Bernard Castle. they have seen different and higher values showing additive genetics, which may account for 50% improvement in performance. Comment is just confused. Any comments on that?
Well, those numbers from Bennett Castle are additive genetics. Yeah. And if you look at individual traits, for example, if you look at butterfat, the heritability is in the 60% range. But if you take all the traits that we look at, the many traits that we look at, then on the average, it's around 20%. And so we just need to be cognizant of the fact that when we talk about genetics, some traits are influenced much more strongly by genetics than others. But as the cow as a whole is about 80% environment and about 20% genetics.
Well, that person just lost. That's good. And that person was not a nutritionist, just so we're fair with you. Another interesting question. Do you see gene editing being accepted? Why or why not, considering considering consumers' knowledge base today?
I see in the long run gene editing being accepted, and the reason I say that is gene editing is moving genes within a species or within a breed that are already there. When we do, let's say we're going to have polled cattle, the genes already exist. We can go through several generations of breeding to get from polled from horn to polled cattle. We can do that with gene editing essentially in one generation. We're not moving a gene from a bacteria. We're not moving a gene from another species. We're moving a gene from one cow to another cow. And so I think that's a different step in terms of genetic modification than genetic engineering typically refers to.
Okay. Another interesting question would be, what will the number of cows per worker be, or will there be nobody there to touch the cow? Any suggestions on that?
Well, there's someone's going to be there, but as we see with automation, we see the number of cows per worker going up, but I don't know what, we haven't actually thought about what the number will be, but maybe now it's 1 per 50 cows on the average, and it may be 1 per 100 or 1 per 150 in the future as we have automation. It really depends on the automation that takes place, but the number of cows per worker will increase substantially.
Okay, this question, I'll just read it to you. I'm not sure I understand it totally, but could you speculate on biosecurity, please? I'm not sure if that means moving on your big platch where you had all your different farms and heifers and calves and that, feed stations, biosecurity. That's the question, Jack. And any reaction to that?
I think biosecurity is going to improve and increase. For example, if you have a group of farmers working together, as we illustrated, where they share some facilities, they're going to have a common biosecurity plan across all of those. And so you probably won't see very many animals moving in from the outside. And you may not see animals going to a fair and exhibition and coming back in unless it's specific protocols that guide that. So we'll see better biosecurity, and sharing biosecurity and protocols among farmers actually helps everyone.
Well, here we go. Okay, this goes back to our question about genetics. Okay, follow up. Heritability is not the same as improving performance. I understand the confusion. Do you see any confusion on that statement or not?
No, I think that's right. I would agree with that. Heritability tends to focus on a specific trait, and performance is multi-trait faceted. So I don't know that we know what the heritability of performance is. In fact, we don't have an estimate of the heritability of performance. We do have a heritability estimate of age of puberty and fat in the milk and so on. But genetically, all of those contribute toward improved performance, but we don't have a number to put on that like we do on specific traits.
We noticed you didn't use the word cloning at all. And of course, last night on CBS, the big deal on cloning horses was on CBS. What about cloning? Is that going to be a problem with consumers, or why did you not mention that?
There's some evidence that we will use cloning, but it will be in the laboratory to go through maybe 4 or 5 generations in the laboratory over a month or so's time. And then an animal will be produced from that. And that cloning in the laboratory will not actually be cloning as we recognize it today. It will actually be breeding among oocytes and spermatogonia, or sperm cells, to make embryos that we can then genetically test and take derived cells from them and go to the next generation. So that's already been done in mice. Paper published recently in cattle show that it's feasible, that we could greatly accelerate the rate of genetic progress. Let's assume we want to breed animals that are resistant to foot and mouth disease, for example. We might be able to do that in the lab in a few months if we had the right genes.
Fascinating, fascinating. Here's your last question, and I think it's an easy one. Will one breed or another be more prominent in the future based on what your research?
We think that there's actually going to be development of lines within breeds. For example, there's no reason why Holsteins won't have a line for the tropical areas that are heat tolerant. They may have a line that's focused on grass-fed production. They may have what we might call a traditional line that we see today. And we can do that now with any breed. There's a question about whether we're going to see more crossbreeding or less. And our speculation is probably going to see less crossbreeding. We may develop some specific lines that have some genes from other breeds, but we'll maintain that line for its function. It'll be 95% Holstein and 5% genes from something else. I don't know what we'll call it, Holstein X, I guess. But that's what we'll see in the future.
Wow, Dr. Britt, just fascinating responses to your questions. I think it's great. Our time is gone. Abby, I'll turn it back to you to finish up. And Jack, you may want to click back to our upcoming programs.
Sure. There we go.
Yes. Thank you, Mike. And thank you, Dr. Britt, for combining all that great research along with a little bit of a look into a crystal ball to try to predict what's going to happen 50 years from now in terms of dairy cows and the dairy farm. So thank you for a great presentation. We also would like to thank De La Valle once again for sponsoring this webinar. Their support was greatly appreciated. And if you want to learn more about their company, feel free to look them up online and get a little more information about what they all have to offer. And as always, we appreciate all of our listeners out there for tuning in to our webinar. And we hope that you found this useful. And we also hope that you will join us again for a future webinar. We'll be getting together again in April on the 9th at noon Central Time to talk about Salmonella Heidelberg. So we hope that you'll consider joining us for that. Until then, we'd like to say goodbye to all of you from all of us here at Hordes Dairyman and our team at the University of Illinois.